Algebra 2, Section 2.6, Special Functions. Today's objectives: write and graph piecewise defined functions, write and graph step and absolute value functions. Today's vocabulary: piecewise defined function, piecewise linear function, step function, greatest integer function, absolute value function. Piecewise defined function. A function that is written using two or more expressions is called a piecewise defined function. On a graph of a piecewise defined function, a dot indicates that the point is included on the graph. A circle indicates that the point is not included on the graph. So we've seen some of this stuff before when we were working with our inequalities. We would have a number line. On the number line, we would have some sort of value, and we would either have a circle if we were not including that value, or we would have a dot if we were including that value. It's going to be very similar, but now we're going to have our 2D graphs. Example 1. Graph f of x is equal to x minus 2 if x is less than negative 1, so there is an inequality, x plus 3 if x is greater than or equal to negative 1. So there's a few things to notice here. Since we have our inequalities and we know about dots and circles, we should know that this first one is going to be a circle, and this second one's going to be a dot. Now, the next thing to look at here, and this is just kind of a visual aid, is that we have this thing, we have these boundary conditions. So here, x is equal to negative 1, we kind of have a boundary. So I'm going to graph a little bit. I'm going to make this line right here at x is equal to negative 1. So to the left of this line, we're going to do one thing. To the right of this line, we're going to do another thing. So let's get started. Let's see. So what we have here is for this top one, we have it in slope-intercept form. So we have y is equal to mx plus b. And we have y is equal to x minus 2. So here our m is equal to 1 because there's that invisible 1 in front of that x. And our b is equal to negative 2. All right, so here's the problem. This one says if x is less than negative 1. So that is going to be our x's on this side of the pink line. The problem comes in here is that we have, if we're going to use our y equals mx plus b, we're going to have to start graphing on this side of the line. So what I'm going to do is I'm going to lightly write, that's my suggestion for you who are using pencil, lightly write and graph this, and then we'll kind of trace it backwards and then write it darker once we get to the other side. All right, so we're going to start off at negative 2. So I'm going to do a negative 2. I'm going to make making my dot a little bit big here because I need to be able to erase it. And we're going to have a slope of up 1 over 1, so that gives me a second dot. That gives me a third dot. I know I should be consistent here. Let's just go ahead and make these big dots. That way they're easy to erase. And then up 1 over 1 again. So what I'm going to get is I'm going to get a line which kind of goes this way. But once again, the problem is that we aren't graphing this side. We need to be on the other side of that pink line. So if we were to continue, we can go backwards. We could go down 1, backwards 1. and then make another dot here. Now I'm actually making a solid dot, because what's going to happen here is I'm going to get my line going this way, and because, let me erase these highlighted things here, and because it's just less than, it's not equal to, we're going to have that open dot. So I'm going to go back and I'm going to erase my light, oops, too big of an eraser. I'm going to go back and erase my light pencil marks there. And now I have the graph for the first half of the piecewise function. The second half will be easier. We're going to be starting at +3. So I'm going to use blue again. Starting at 1, 2, 3 on the x. I can make a dot there because it does actually allow me to be there, because we're at x is greater than or equal to -1. And we still have that slope of 1, so we're going to go up 1 over 1, up 1 over 1. And we probably want to go all the way backwards. And I'm going to go ahead and make a circle here because, once again, we have that greater than or equal to. Since it's equal to, we get to make, sorry, the dot, not the circle. Now I can go ahead and connect these dots. And there we go. There's our first piecewise defined function. So at x is equal to -1, we have two different things happening here. One of them, we had on the left a line pointing downwards like this. On the right, we had a line pointing upwards like this. And we've got this whole distance that are separated. So it's not just one line. We have two lines for one function. All right, so we're going to make my head disappear because we cannot see. There we go. We're going to write a piecewise defined function shown in the graph. So here we now have 3 lines. So we're going to make our f of x. I'm going to make my big brace right there. I'm going to have 3 different equations. So what I'm going to try to do here is I'm going to try to notice that we have things happening at 2 different places. I'm going to kind of highlight this here. We've got something happening at x is equal to +1. That's where we have the splits. And we're going to also have something happening here at x is equal to +2. Once again, we have more splits there. So the first one is going to be for x is less than 1. And I have just a less than because what we have going on here is we have that open dot. Since it's an open dot, we don't have the equals to. I'm going to go ahead and do the one on the far right now. On the far right, we're going to have x is greater than 2. Once again, I've got just greater than, no equals to, because we have that open dot. And in the middle there, we're going to have something a little bit more complicated. We're going to have 1 is less than or equal to x, which is less than or equal to 2. So we've got the equals to because we've got that solid dot, and that right there is x is greater than or equal to 1. Once again, we have this equals to here because we have that open dot right there. And now it's just a matter of trying to figure out what these equations are. Well, if we go up 1, 2, 3 places, we can see here that we're going to have a y-intercept at y is equal to 3. So I'm going to get something like y is equal to x with a +3. The question now comes down to what goes right here? What's our slope? Well, let's find out. We're going to be going up 1, 2 places before we get to the next dot. And then we're going to also be going over 1. So rise is 2, run is 1. So we're going to get a 2 over 1, or simply just a 2. So for the first part of this piecewise function, we're going to get y is equal to 2x plus 3. All right, let's move on to the next portion. We're going to need to try to trace this line backwards a little bit so that we can find out where our y-intercept is. So I'm going to start off and I'm going to kind of trace it backwards, and it looks like it would cross right there at 2. So for the second one, I'm going to get a plus 2. We're going to have an x. We're going to have a y equals. And once again, the question comes down to what is our slope? What goes in front of the x here? Well, if we try to do this again, we're going to be going down 1 and over 1 to get to our first points. So a down 1 and over 1 is simply just a -1. So our second equation is going to be y is equal to -1x, or just -x. Make that look a little bit nicer. -1x. I should probably move over my boundary conditions. Let's make some room. And then we had plus 2. All right, I'm going to change my boundary conditions color just so that way they don't look like they're part of the problem. Okay. And then the last one we have here, we have a horizontal line. We have a horizontal line at 1, 2, 3 places up. So we're going to get just y is equal to 3. All right, that was a lot of work. All right, example 3. An automotive repair center charges $50 for any part of the first hour and $35 for any part of each additional hour. Draw a graph that represents this situation. All right, so we're going to start off here with a step function. A step function is, well, it's kind of what it sounds like. We're going to have little steps, kind of like stairs or ladders. So for the first hour, we're going to have it costing, what should we make this? Let's go up by 10s, 15s. We'll go up by 5s. So this will be 5, 10, 15, 20, 25. I don't think we have enough room here, so let's go ahead and change our grids. That's better. Okay. So once again, going up, I'm going to go up by 5. So now each square will be 5. So that means every 5 squares will be 25, because 5 times 5 is 25. So 1, 2, 3, 4, 5. That right there is going to be 25. 1, 2, 3, 4, 5. That will be 50. And, well, we're going to want to know where 35 is, so I'll just go ahead and make it a pink line and say that is my 35. And then we'll just continue going up. 1, 2, 3, 4, 5. That gives me 75. 1, 2, 3, 4, 5. Gives me 100. And we'll stop there. All right, just because it's going to be kind of a weird graph, I know, I'm going up by 5s. I'm going to go ahead and say that every 5 on the other side is 1 hour. So right there, I'm going to have a 1. Right there, I'm going to have a 2. Then a 3. A 4. A 5, and a 6. So as long as we label how our graph goes, we can kind of make it how we wish. All right, so here we go. We're going to graph this. So, oh, we don't need this 35 here. Made mistake. That's okay. We can fix it. So for any part of an hour, let's move my head out of the way because it wasn't originally, but now it is. An automotive repair center charges $50 for any part of the first hour. So we can be in this shop, and if we're in there for 5 minutes, it's going to cost us $50. If we're in there for 15 minutes, it's going to cost us $50. If we're in there for 59 minutes and 59 seconds, it's going to cost us $50. So what's going to happen here is we're going to have a graph which from time equals 0 all the way to time equals 1 hour, it's going to cost us $50. And let me go ahead and make this a little bit thicker. So this is our step function. This right here, it kind of, oh, that's too big. This kind of looks like a step, a stair. So for that first hour, regardless, it's just $50. Now from there, for every hour afterwards, it's going to cost an additional $35. So we're going to have to go up by 35. So let's just kind of trace things here. So here's our hour 2. That didn't become straight. There we go. There's hour 2. There's hour 3. Because we have so many squares, it's going to be better to see where these things are. So we're going to want to go up by 35. All right, well, 50 to 75 is just 25, so we need to go up another 2 from there. So then we're going to have right here a dot. Or if you're good at math, because we're in Algebra 2, 35 divided by 5 is 7, so we can always just go up 7 more squares. So now I'm going to do it one more time, see if I have room. I'm going to go up 1, 2, 3, 4, 5, 6, just barely reached it. Okay, cool. So what's going to happen is for that first hour, it's going to cost us $50, and then it's going to kind of move upwards like this afterwards for each additional hour, or each additional part of an hour. Oh, actually, no, that's not right. This whole thing is a step function. So then from here, after the first hour, we're going to get another line like this. I need to reread it. So it said, and $35 for any part of each additional hour. So once again, it doesn't matter how much time we're spending here. It's going to cost that much money. And then the last one, we just have another step here. So now this legit looks like a step on some stairs or a ladder or something. But the question comes down to what's going to happen here. Do I actually have dots there, or do I have circles there? Well, up until 2 hours. So what's going to happen here is at 1 hour, which is right here, it's going to cost $50. That's going to include exactly 1 hour. So we're going to have a dot right there to say all the way including. Now the other one also begins at 2 hours, but until we get 2 hours and 1 second, it's still going to cost $50. So we're going to need to have a circle there. And then it's going to cost that additional $35 more until we get to the end of the 2 hours, including the 2 hours. But then we jump up again, and once again, we're not going to include this amount until we get to 2 hours and 1 second, and so forth. Okay, so I think I confused us sufficiently here, so let's go ahead and do this again. So the automotive repair center is going to charge $50 for any part of the first hour of labor. So that's this right here. There's our $50. And as far as any part of the first hour, which includes the actual 1 hour mark. then it's going to cost an additional $35 for any additional hour. So here, because we're only spending the $50 at the beginning of the 2 hours, we have the open circle on the far left. And then it's going to cost that additional $35 all the way to the end of the second, or beginning of the second hour. But we're going to have our closed circle there, our dots, because that includes up until the second hour. And then we jump up again for the next hour. So we're going to start at 2, but we're going to have that open circle because we're not going to be charged another $35 until after that first second of that next hour, and then so forth. So here we got a bunch of steps going upwards. All right, well, come and see me in class if we have questions about this. My apologies. I should read better. All right, now we're going to have our absolute value function. So here I'm going to point out, you need to know this graph. I can guarantee you're going to need to know how to graph this graph. You're going to need to know how to recognize this kind of graph, both for, actually not just both, but for quizzes, for tests, midterms, finals, all that good stuff. So f of x is equal to the absolute value of x. So we're doing absolute values again, but now we're doing them with both x's and y's, because as we know, f of x just means the letter y. So now we have x and y, not just x, or not just any letter. All right, so this is a piecewise function. And for x being greater than 0, that's this portion, we're going to have the equation y equals x. And I'll go ahead and add a plus 0 because that is our y-intercept. We're crossing the y-axis at 0. Then we're going to have for x is equal to 0. We get just a little dot right there. Just a dot. So let's make a dot. Okay. There's a dot. And then finally, if we're going to have x being less than 0, we're going to have the exact same line as the first one, but with a negative slope. And if it makes you feel better, we could go down 1 and over 1, and we would get another dot right there. So there you could kind of see that, yes, this line does in fact have that negative slope. Oh, okay. My numbers are a little bit off here. So this is 1 here, and then halfway between 0 and negative 2 is 1. Halfway between 0 and 2 is 1. So we do have those slopes. It's just the bottom numbers are going by evens, and the y-axis we're going up by ones. All right, so one last example. Graph f of x is equal to 2x minus 4. Identify the domain and the range. Okay, so here's our first little trick. In an absolute value, we want to set this part equal to 0. I'm going to call this the ugly part. So we want to set the ugly part equal to 0 and solve for x. This is going to give us our starting points on the graph. So if I do this, we're going to get a 2x minus 4 equals 0. Solving for x, we first add 4 to both sides and get 2x is equal to 4. Then we will divide both sides by 2 because we want to leave the x where it is, but get it by itself. That will cross those out. And then we will get x is equal to 2. So when we set the ugly part, I'm using air quotes there, equal to 0, we get here for our absolute value that little point on the v. So we're going to say that x is equal to 2 is the tip of our v. Now we just need to worry about using our slope to keep going up. Well, our slope, which I'm going to kind of point out here, is going to be plus or minus whatever the number is in front of the absolute values. As we may or may not know, when we don't write a number in front of something, there is that invisible 1. So our slope is going to be plus or minus 1. So the plus, we're going to be going up 1 over 1, up 1 over 1, up 1 over 1, and getting a bunch of dots like so, which will give us this side of the absolute value. And then on the other side, we're going to have to go up 1, backwards 1, up 1, backwards 1, up 1, backwards 1, and then getting a whole bunch of dots like so. And then getting the other side of the v. And that's it. Oh, that's right, we need to find the domain and the range. So if we recall, domain, let's scroll this over. Domain is all of the x's that we have here. So since our domain consists of an arrow pointing to the left and to the right, by the way, your domain for all absolute values, I'm going to repeat that. Your domain for all absolute values is just going to be a negative infinity, comma, infinity, if you like the interval notation. Or if we're doing the set builder notation, it'll be x for all real numbers. The range is the y values. So we need to look to see where is our most negative y on the graph. Most negative doesn't mean that it's actually negative. It just means that it's the closest thing to the negatives. So here we can see that's happening at y is equal to 0. So if we're using our interval notation, we're going to have 0. And then we notice that our arrows are both pointing upwards. So they're going to go up forever and ever and ever. So it's going to be 0, comma, infinity. And once again, that's because these arrows, if you didn't see me writing those, are pointing upwards forever. We're going to get that. And with our set builder notation, we're going to get y for y is greater than or equal to 0. So pick one, interval notation or set builder notation. I'll be using them both. All right, now we're done. Now we actually solved the problem.